The man who rewrote the laws of the universe could not keep his marriage from falling apart, could not stop his son from spending the rest of his life inside a psychiatric institution, and could not get a single colleague at Princeton to take his life's work seriously for the last 30 years of his life. That is not the Einstein on the poster on your wall. That is the real one. And here is the part the biographies almost always skip when he died. His brain was stolen, cut out of his skull without permission, driven across the continental United States in a Tupperware container, and stored under a beer cooler in a Kansas apartment for decades. The man who explained the universe to the human race could not, in the end, even keep his own body together. I want to tell you the full story, not the bumper sticker version, not the white hair and the tongue and the chalkboard, the actual story, which is far stranger, far darker, and far more interesting than anything they taught you in school. Albert Einstein was born in Ulm, Germany, on March 14th, 1879. 1879. That is the same decade that Thomas Edison invented the light bulb, and Sitting Bull was still fighting the United States Army. The world he was born into had no cars, no planes, no radio. The fastest thing most people had ever seen was a train. He would live long enough to see nuclear weapons, television, and the beginning of the space age. He would be responsible for some of it and horrified by most of it. His childhood was unremarkable in the ways that made adults nervous. He was late to speak. His family worried. His teachers found him difficult. Not because he was stupid, he was obviously not stupid, but because he had a deep, almost aggressive resistance to being told what to think. He later described the educational system he grew up in as something close to a machine designed to destroy curiosity. He was not being dramatic. He genuinely believed that most of what schools did was train children out of their instinct to ask why, and he spent his entire life in quiet, sometimes not so quiet, rebellion against that process. He failed his entrance exam to the Swiss Federal Polytechnic in Zurich the first time he took it. He was 17. He did fine on the mathematics and physics sections. He bombed the French section, the botany section, and the zoology section, which honestly tells you everything you need to know about the kind of mind he had. He was not interested in memorizing. He was interested in understanding. Those are two very different things, and the education system of 1895 had very little patience for the distinction. He got in the following year, and that is where he met Mileva Marić. Stay with me, because Mileva's story is the one that runs underneath everything else I'm about to tell you. And by the end of this, you are going to understand why she matters more to the history of physics than almost anyone has been willing to admit. Mileva Marić was Serbian. She was one of the only women in Europe admitted to study physics at the level Einstein was studying it. She was brilliant, careful, methodical, everything. Einstein was not on a day-to-day basis. He was electric and scattered. She was precise. They fell in love over physics, textbooks, and long walks, and letters that were so full of equations and affection they are genuinely difficult to categorize. He called her his equal. He said she was the one who made his ideas rigorous. He said, in writing, that the work they were doing was their work. I am going to come back to that, because it becomes important. Very important. Einstein graduated in 1900, could not get an academic job because his professors found him arrogant, which, fair, and eventually landed a position as a patent clerk in Bern, Switzerland. Third-class examiner. He reviewed other people's inventions for a living. He was 23 years old and completely invisible to the scientific world. And then came 1905. Physicists call it the Annus Mirabilis, the miracle year. In the span of roughly 12 months, working alone, with no laboratory, no funding, no institutional support, and no professional standing, Einstein published 4 papers. Not 4 good papers. 4 papers that each, individually, would have made a scientist's career. Together, they restructured the entire foundation of physics. The first one explained Brownian motion, the random jiggling of particles suspended in liquid, and in doing so, provided the first real experimental proof that atoms exist. Atoms. Scientists have been arguing about whether atoms were real or just a useful mathematical fiction for roughly 2,000 years. Einstein ended that argument with a piece of paper. The second one explained the photoelectric effect, why shining light on certain metals causes them to emit electrons. He explained it by arguing that light is not just a wave, but also comes in discrete packets of energy, which he called quanta. This was the paper that would eventually win him the Nobel Prize in Physics in 1921. Not relativity. The Nobel Committee was still nervous about relativity in 1921. More on that in a moment. The third paper introduced the special theory of relativity. Time slows down at high speeds. Length contracts. Mass and energy are the same thing, related by the speed of light squared, E equals mc squared. He was 26 years old. The fourth paper was a follow-up to the third. It derived E equals mc squared from first principles, in a paper that was less than 3 pages long. For comparison, most graduate students today spend 5 years producing a single doctoral thesis. Einstein produced 4 field-altering papers in 1 year in his spare time while working a day job. The universe apparently did not get the memo that this was not how physics was supposed to work. Here's what I want you to hold on to, though. By 1905, Mileva Marić was no longer studying alongside him. She had left the program. She had failed her final exams twice. She had given birth to their daughter Liesl in 1902, a child who appears in their letters and then simply vanishes from the historical record entirely. Nobody knows what happened to her. Some historians believe she died of scarlet fever. Some believe she was given up for adoption. Einstein never spoke of her publicly for the rest of his life. Not once. Mileva and Albert married in 1903 after Liesl disappeared. They had 2 more children, Hans Albert and Eduard. And the question that historians and physicists have been fighting about for decades is this: how much of the work in those 1905 papers was actually Mileva's? Einstein's letters to her used the word "our" to describe the research, consistently. There are accounts of colleagues who heard him say that his wife solved his mathematics for him. After they divorced, she received a substantial portion of the Nobel Prize money as part of the settlement money she used to buy apartment buildings in Zurich, which she then used to fund Eduard's care. Eduard would later be diagnosed with schizophrenia and spend much of his adult life institutionalized. Einstein would visit him only once after leaving Europe. In 1933, once. But I am getting ahead of myself. General relativity arrived in 1915, 10 years after special relativity. Special relativity had been a thought experiment about trains and lightning bolts. General relativity was something else entirely. It described gravity not as a force, but as a curvature in the fabric of space-time itself. Mass bends space. Space tells mass how to move. The Earth does not orbit the sun because the sun pulls it. The Earth follows a straight line through curved space, and that straight line happens to loop around the sun because the sun's mass has bent the space around it. This was not a small idea. This was the complete replacement of the framework Isaac Newton had given the world in 1687. Newton's gravity had worked perfectly for 228 years. Einstein said it was a useful approximation of something deeper. And he was right. In November of 1919, a British astronomer named Arthur Eddington published the results of an expedition he had led to observe a solar eclipse. The point of the expedition was to measure whether the light from distant stars was bent by the gravitational field of the sun, exactly as general relativity predicted. The answer was yes. The bending matched Einstein's equations to within the margin of experimental error. Overnight, literally overnight, Einstein became the most famous scientist in the world. The timing mattered enormously. This was 1 year after the end of the First World War. Europe was exhausted, grieving, and desperate for something that was not about territorial borders and artillery and trenches. A German Jew and a British scientist working together to confirm a theory about the nature of reality itself, it was almost too perfect, a symbol for what people wanted to believe was possible. The newspapers went wild. His face was everywhere. He became the first scientific celebrity in the modern sense, the first scientist whose name and face were recognizable to people who had never read a word of physics. He hated it. Or at least, he said he hated it. He complained constantly about the attention, the fan mail, the lecture invitations, the journalists who camped outside his house. He joked with what his biographers describe as genuine weariness. that he had become a myth while still alive, which meant he had effectively stopped being a person. The Nobel Prize came in 1921, as I mentioned, for the photoelectric effect, not for relativity. The committee was cautious. There were still physicists who questioned whether relativity had been properly confirmed. There were also, more darkly, a number of prominent German physicists who had begun a campaign to discredit Einstein's work specifically because he was Jewish. They called it Jewish physics. They organized public lectures against it. One of the men who led this campaign had himself won a Nobel Prize. Einstein dismissed them publicly and repeatedly, sometimes with a wit so dry it could have stripped paint. He was already watching the political situation in Germany with the kind of dread that only someone paying close attention could feel in those early years. Most people thought Adolf Hitler was a temporary embarrassment, a loud noise that would eventually fade. Einstein was not most people. In December of 1932, Einstein left Germany for the United States. He was heading to Princeton, New Jersey, to spend a few months at the newly formed Institute for Advanced Study. A few months became forever. In January of 1933, Hitler became chancellor. In February, Einstein announced he would not return. The German government responded by raiding his house, seizing his assets, and eventually stripping him of his citizenship. They also put a price on his head. Literally, there were Nazi publications that ran photographs of prominent Jewish intellectuals under the heading, "Not Yet Hanged." Einstein's photo appeared with a caption that confirmed the bounty was substantial. He settled at Princeton. He bought a house on Mercer Street. He walked to his office every day. He gave lectures. He played violin badly and with enormous enthusiasm. He became something of a local legend, the friendly old man with the wild hair who would talk to anyone who stopped him on the street, including and especially children, who he seemed to genuinely prefer to most adults. And here is where the story turns. Here is where the mythology and the reality begin to separate in a way that matters. The scientific community had moved on. While Einstein had been building general relativity, while he had been handling fame and politics and two marriages and the League of Nations and anti-war activism and everything else, physics had kept moving. Quantum mechanics had arrived. Niels Bohr, Werner Heisenberg, Erwin Schrödinger, Paul Dirac, a whole generation of physicists, had built an entirely new framework for understanding the behavior of subatomic particles. And it worked. Quantum mechanics was the most successful predictive theory in the history of science. It was also deeply, profoundly strange. At the quantum level, particles do not have definite positions or velocities until you measure them. Measurement itself changes the thing being measured. Reality at the smallest scales appears to be fundamentally probabilistic, not deterministic. God, in the famous phrase, plays dice. Einstein refused to accept it. Not because he was old and stubborn, though that is the easy story. He refused because he genuinely believed quantum mechanics was incomplete. He believed there had to be a deeper layer of reality underneath the probabilities, a set of what he called hidden variables, a deterministic foundation that quantum mechanics had not yet found. He spent the rest of his life trying to build what he called a unified field theory, a single mathematical framework that would reconcile general relativity with quantum mechanics and show that the apparent randomness of the quantum world was just ignorance of deeper structure. He worked on it for 30 years. He published paper after paper. And in the judgment of virtually every physicist at the Institute for Advanced Study, the colleagues he walked to work with, the people who respected him enormously as a historical figure, he was wasting his time. That is a hard sentence. Let me say it more plainly. The greatest physicist who had ever lived spent the last 30 years of his career on a problem that his colleagues believed was not solvable in the way he was trying to solve it, using mathematical approaches they considered outdated, in a direction they thought was wrong. His office at Princeton was not a hub of excitement and collaboration. It was a place where a very famous, very isolated man worked alone, almost every day, on something nobody around him believed would work. He knew they thought this. He did not stop. There is something worth sitting with here. Because we tend to think of stubbornness as a defect in a person, as the thing that makes ordinary people fail. But Einstein's entire career had been built on a refusal to accept the consensus view of reality. In 1905, the consensus view was that atoms might not exist, that light was purely a wave, that time was absolute. He ignored all of that. He looked at the evidence and followed his intuition about what the equations were telling him, regardless of what everyone else believed. That stubbornness had been his superpower. At Princeton, in the 1940s and 1950s, it became his cage. There is a parallel story I want to draw here because it reframes everything I have just told you. In the 1940s, a young physicist named David Bohm arrived at Princeton. He was brilliant, unconventional, and deeply interested in the same foundational questions that Einstein was wrestling with. He actually did develop a version of quantum mechanics with hidden variables, exactly what Einstein had been insisting must be possible. It was called the pilot wave theory, and it was mathematically equivalent to standard quantum mechanics. It worked. The physics establishment buried it. Not because it was wrong, because it was inconvenient. Because the Copenhagen interpretation championed by Bohr and Heisenberg had already won the political and institutional battle within physics. Because careers had been built on it, textbooks had been written around it, and the last thing the community wanted in the early 1950s was someone arriving with a reformulation that implied their entire interpretive framework had been optional all along. Bohm was eventually run out of the United States entirely during the McCarthy era, accused of communist sympathies, stripped of his Princeton position, and forced to spend his career in Brazil and then England. Einstein supported him, wrote him letters of recommendation, defended him publicly, did not have enough institutional power anymore to actually protect him. Einstein had been the revolution once. By the 1950s, he was outside, looking in at a new establishment that had no more room for him than the old one had for the young man at the patent desk in Bern. Now here is the part I told you I would come back to, the part about Mileva. After their divorce in 1919, Einstein had quickly remarried his cousin, Elsa. Elsa was warm, practical, socially comfortable in ways Einstein was not, and completely uninterested in physics. She managed his household, managed his schedule, managed the endless stream of visitors and journalists, and died in 1936 in Princeton, leaving him alone in the house on Mercer Street with his stepdaughter Margot and his secretary Helen Dukas, who would become his fierce and devoted protector for the rest of his life. Mileva, meanwhile, was in Zurich, managing the apartment buildings, caring for Eduard, who had become unmanageable by his 20s, hearing voices increasingly disconnected from reality, hospitalized repeatedly. She spent the money from the Nobel Prize almost entirely on his care. She had a small circle of friends, but was largely forgotten by the scientific world she had once been a part of. She died in Zurich in 1948, after a stroke, alone in her apartment. Her body was not found for several days. I want you to hold that image for a moment. Mileva Marić, who may have contributed to the most important scientific papers of the 20th century, who had given Einstein 2 sons, who had spent her adult life in the shadow of a fame she had some hand in creating, dying alone in an apartment while Eduard slept unaware in a hospital across the city. And then, 7 years later, Einstein. April 18th, 1955. Princeton, New Jersey. Einstein had been in the hospital for several days with an aortic aneurysm, a bulge in the main artery of the heart that had been diagnosed years earlier and that he had refused to have surgically repaired. He was 76 years old. When the doctors told him surgery might extend his life, he told them he had done his share and it was time to go. He said he wanted to leave when he wanted, not be kept alive artificially. There is something almost enviable about that level of clarity. In the hospital, in his final hours, he asked for a pad of paper and his glasses so he could keep working on the unified field theory. His last act on this earth was attempting to find the equation that connected gravity and electromagnetism. He was still looking. Even then, the nurse who was with him through the night spoke no German. He died in the early morning, around 1:15, still reaching for something that was not quite there. He had specified in advance that there should be no funeral, no grave, no monument. He wanted to be cremated and have his ashes scattered in an undisclosed location so that, in his words, people could not turn the place into a shrine. And this is where the story becomes genuinely surreal. The pathologist who performed the autopsy was a man named Thomas Harvey. Harvey was competent, thorough, and apparently overcome by what we might generously call an excess of historical enthusiasm. Without authorization from Einstein's family, without any formal request, Harvey removed Einstein's brain during the autopsy and kept it. He kept it for 43 years. When Einstein's son, Hans Albert, found out, he was furious. Then he was talked into a kind of resigned acceptance on the assurance that Harvey would use the brain for legitimate scientific research. Harvey did eventually publish some findings decades later in collaboration with other researchers, but mostly he just kept the brain in jars in his house. He moved from Princeton to Kansas, and the brain went with him. He kept it under a beer cooler at one point. He kept it in a cider box. He carried it around the country in a Tupperware container. He was not a villain. He was just a man who had gotten hold of something extraordinary and could not figure out how to let it go. In 1998, a journalist named Michael Paterniti drove across America with Harvey and the brain in the car. Harvey was then in his 80s. They went to California to visit Einstein's granddaughter, Evelyn. Harvey brought the brain. He apparently hoped to give it back to her. She declined. He eventually returned it to Princeton Hospital, where it should have gone in 1955. Let that settle for a second. The man who proved that space and time are not what we thought they were, who showed that energy and mass are two forms of the same thing, who predicted black holes, gravitational waves, the bending of light, the expansion of the universe. His brain spent 4 decades in a Tupperware container in Kansas. I am not sure the universe has a better sense of humor than that. But here is what I keep coming back to. The lonely death, the stolen brain, the failed unified theory, these are the strange footnotes. They are real and they are remarkable. But the thing that actually stays with me when I go deep into Einstein's life is something quieter and harder to name. He was not failed by circumstance. He was not unlucky. He chose almost everything that isolated him. He chose the ideas over the relationships repeatedly, systematically, across his entire life. He treated Mileva as a collaborator, and then as a domestic servant, and then as a stranger. He was largely absent from his sons' lives, including Eduard's illness, which he once described in a letter with a coldness that is genuinely difficult to read. He poured everything, every hour, every ounce of cognitive energy into the work, and the work repaid him, for a while. The tragedy is not that the universe is indifferent to human suffering. Einstein knew that. He would have told you that directly. The tragedy is that the man who understood more about the structure of reality than anyone who had ever lived could not translate that understanding into anything warm enough to hold on to at the end. He solved for the geometry of space-time. He could not solve for the geometry of a son's grief or a wife's loneliness, or the specific kind of isolation that comes from being so far ahead of everyone around you that conversation stops being possible. There is a question buried in this story that I think is worth sitting with, though I am not going to pretend I have an answer to it. The question is this: what do we owe the people who make our world? Not the famous ones, the Mileva Marić, the Eduard Einsteins, the people who orbit genius and get burned by it, who contribute to the light that history remembers under one name. The unified field theory, by the way, remains unsolved. The project Einstein gave his last 30 years to reconciling general relativity and quantum mechanics is still one of the great open problems in physics. String theory, loop quantum gravity, every attempt at what physicists now call a theory of everything is a descendant of what Einstein was reaching for in that Princeton office. While everyone politely declined to take him seriously, he was not wrong to try. He was just too early. Again, he was always too early. That was his entire life. He was ahead of the physics of 1905 when he published in 1905. He was ahead of the cosmology of 1917 when he derived equations that implied an expanding universe, and then, famously, introduced a fudge factor called the cosmological constant to make the equations produce a static universe instead, because an expanding universe seemed too strange to be true. 13 years later, Edwin Hubble confirmed that the universe was expanding. Einstein called the cosmological constant the biggest blunder of his life. In the late 1990s, physicists discovered dark energy, which behaves in almost exactly the way his cosmological constant described. His blunder turned out to be right, accidentally, which is almost too on the nose. He was right about things he thought were wrong. He was right about things nobody would confirm for 50 years. Gravitational waves, which he predicted in 1916, were first directly detected in 2015. That is 99 years. He predicted the bending of light around massive objects, confirmed in 1919. He predicted that clocks run slower in stronger gravitational fields. That is called gravitational time dilation. And it is real, and your GPS satellites have to correct for it, or they would give you directions that diverge by several miles per day. He did not live to see most of this confirmed. He died still being argued with, still being dismissed in certain corners, still fighting for a vision of physics that the establishment considered finished. There is a version of this story that is inspirational. The lone genius against the world, the man who trusted his own mind when everyone else said he was wrong. I have been telling that version for part of this video, and it is true as far as it goes. But there is another version, and I think it is the more honest one. The version where a person can be right about the universe and wrong about the people who love them. Where intelligence of the highest order does not protect you from loneliness. Where the same quality of mind that lets you see things no one else has ever seen also makes it nearly impossible to stay present in a room with another person who just wants to feel seen themselves. Where the greatest achievement and the deepest failure can come from exactly the same source. Einstein once wrote, in a letter to a grieving friend, that death is not as terrible as it might seem because the distinction between past, present, and future is only an illusion. That time does not pass. That the moments we have lived are, in the structure of space-time, permanently real as anything that exists now. He believed this. He derived it. He found it genuinely comforting. I think about that letter when I think about Mileva dying alone in Zurich in 1948. I think about Eduard, who outlived his father by 11 years, who died in a Zurich psychiatric hospital in 1965, having never really understood what his father had done or why he had been so far away for so long. If Einstein was right about time, and we have every reason to believe he was then somewhere in the geometry of the universe, the young man at the patent desk in Bern is still writing. The letters to Mileva still say, our work. The baby Liserl is still alive, at least for a moment. The eclipse of 1919 is still bending starlight for the first time. The needle is still descending onto a recording of the Brahms Violin Sonata in the house on Mercer Street. All of it still real. All of it still happening. Permanently in the four-dimensional structure of space-time that he spent his life describing. He changed the world. He changed how the world sees itself, how it understands its own origins, its own structure, the fabric of the space it exists inside. No single human being in the 20th century rewrote more of what we know to be true. No single mind produced more confirmed predictions about the nature of physical reality. And on April 18th, 1955, at 1:15 in the morning, in a hospital in Princeton, New Jersey, he said something in German to a nurse who spoke only English, and then he was gone. She did not understand what he said. Nobody ever found out. The posters are still on the walls. The formula is still on the coffee mugs. The tongue is still sticking out. The myth is still everywhere. The man dissolved back into the space-time he spent his life trying to understand which, if his equations are correct, means he was never really gone at all. He was just somewhere we cannot see yet.